Assalamualaikum. My name is Abdul Fattah Iskandar bin Abdul Malik. Today we would like to present about 3D printed prosthetic legs. For introduction, firstly the purpose. The prosthetic legs is built to support patients with leg disabilities through affordable prosthetic. Secondly, approach. Apply project management and finance methods on this project. Lastly, focus. We focus on smart objectives, WBS, CPM scheduling, budgeting and risk management. Now we move on objective and scope. We fabricate and design 5 prosthetic legs within 8 weeks. We also use SMART criteria, which is specific, measurable, achievable, relevant and time bound. For scope, we start with consultation. Next, measurement, design, printing, assembly, fitting and handover. This is the SMART objective. Work breakdown structure. We break down 5 phases for this part. Firstly, project initiation. We get approval from Pekeso Ipoh and also formation of project team. Next phase is patient assessment. We provide patient consultation and also taking leg measurements. Other than that, design phase. In this phase, we use 3D modeling software and also review and improve the designs. Moreover, fabrication. We start to use 3D printing prosthetic leg by parts. And also, we do material inspection for each prosthetic legs. Last phase is delivery. We do final patient fitting and official handover to patients. That's all from me. Presentation will be continued by Azizul.
Thanks to my friend Fatah. Now I want to continue the presentation, and my name is Azizul. In this project, we come up with 5 designs of prosthetic legs that include above knee and below knee. For the design, we come up with its material also, such as PETG, ABS, carbon fiber, PLA. TPU is a flexible materials. It used in cushioning and its elasticity helps absorb impact during walking. For comfort, we use medical grade silicone to enhance comfort and reduce pressure points. For fastening, we use Velcro straps and metal screws. It's easy adjustment of the prosthetic leg to achieve proper fit and comfort. And the metal screws provide secure fastening between components. For quality control, we have steps. First, careful measurement of patient legs, then design review before printing. After that, trial fitting sessions, and lastly is feedback from patients. Next slide is about timeline and scheduling. We come up with Gantt chart for this project. Week 1 to week 3 we use to patient consultation and measurement. Then week 3 to week 5 it's used to 3D modeling and design. Week 5 to 6 for 3D printing. Week 6 to week 8 is used to assembly and testing, then fitting and final handover. This project we use critical path method, CPM. This method have steps. First measurement, then design, then printing, and last is fitting. For the first week to week 3 we have patient consultation and measurement. Its accurate limb measurements and patient assessments are completed first. Then steps 2 we have 3D modeling and design for week 3 to 5. For this week, the prosthetic socket and leg structure are digitally designed based on measurements. Steps 3 3D printing from week 5 to week 7. The design prosthetic components are fabricated using 3D printing. And the last step is fitting and final handover from week 6 to week 8. In this week, final fitting, adjustment and patient handover are completed. Any delay in these steps would delay the whole project. Why this method is critical? Because this task cannot be skipped. Then printing cannot start before the design is finalized, and fitting cannot happen before the prosthetic is printed. That's all from me. Now I want to pass to my friend Haikal to continue the presentation.
Thank you, Azizul. Now it's my turn. My name is Muhammad Haikal Izham bin Fairil, and I will talk about the cost budget, the challenge and risk management, and the conclusion for this topic. So for total direct cost, we have three items, which is 3D printing filament, silicone lines and straps, and 3D modeling software license, which is start at 600 ringgit, 1,000 ringgit and 400 ringgit, and the total is 2,000 ringgit. So for total indirect cost, we have two items, which is transportation to Perkasa Ipoh and contingency fund, which is 400 ringgit and 800 ringgit. The total is 1,200 ringgit. So lastly, for startup costs, we have commercial 3D printer. It estimate around 4,000 ringgit, and the total for direct cost, indirect cost and startup cost is 7,200 ringgit. Now I want to talk about the challenge and risk management. For our first risk category, we have equipment failure. 3D printer may fail during production, and the impact will delay in printing process. So for mitigation strategy, we recommend to do regular maintenance, test printing before final production, extra filament preparation, and backup printing schedule. Now I want to talk about the second risk category, which is improper fit and patient discomfort. The prosthetic may not fit correctly and may cause pain, so it will make patient discomfort and repeat adjustment, delay in final handover. So for mitigation strategy, we want to do an accurate 3D scanning, multiple fitting session, quality control inspection, and patient feedback during fitting stage. For the last challenge is schedule delay. Problem is patient may be unavailable for consultation, fitting session or follow-up appointment. Possible impact will delay in project completion and disruption of critical path. So for mitigation strategy, early appointment scheduling, we will do strong communication with Perkasa Ipoh management and addition buffer time in project schedule. So, in conclusion, this CSR project prosthetic leg at Perkasa Ipoh demonstrate how engineering technology and project management can work together to create meaningful social impact. The use of 3D printing technology provide a cost-effective and flexible solution for prosthetic development compared to traditional manufacturing method, and it's allow faster production, easy design modification, and better customization based on patient physical condition. Proper budgeting strategies, quality control, and risk management also play an important role in ensuring project success by reducing technical failure, fitting problems, and schedule delays during implementation. Okay, that's all from us. Thank you.